our capstone project is Maze Escape, and our team is Team Feta. So I'm Sarah. I did mostly game object interactions.
My name is Neha. I did most of the HUD and map layout.
My name is Johnson. I did the middle VR integration and lots of the assets you'll see in the game.
My name's Jason. I did most of the maze rendering.
My name's Grant. I did a lot of the combat and scoreboard and stuff.
So our project is a cave VR game, and it's basically a maze that changes dynamically each time the player plays, and it's spawning random monsters that kind of chase you and you can interact with, as well as potions that can be picked up and treasure chests that can be opened.
Time for a demo.
I'll get the lights.
Alright, so here's our demo. Grant's gonna start with the tutorial.
Yeah, I'll start with the tutorial. Welcome. This project was created by Team Feta for our Capstone project. Continue through this mini maze to advance through the tutorial. So you have a health bar next to your gun. Walk over health potions to restore your health. If it drops to 0, you'll be returned to the main menu. Press the trigger on the wand to fire the gun. Press the leftmost button on top of the wand to interact with health potions and treasure chests. Red enemies are stationary, but blue enemies will chase you. So here's some of the red enemies to practice on. You can fire the gun and it'll eliminate them. And also grab some health potions and treasure chests. And then find this door to reach the exit and win. So here's we're back in the main menu. Now I can actually start the game. So some blue enemies, chests that you can collect. And there's only one path that'll get you to the actual exit. Okay, run into some more blue enemies. Collect another treasure chest. The red enemies just stay there. Run into a lot more enemies. Took some damage from that one.
That makes sense.
Some treasure chests. I get this health potion to get back my health. If I turn left here, there's the exit. I got 1 minute and 12 seconds with 4 chests collected. I can quit out of that. That's the demo.
Alright, so there were a number of different maze generation algorithms that we looked at. One that we ended up using was called recursive backtracking. It's a path carving algorithm, so you start with a grid with every maze wall active, so it's like a grid basically, and then you carve a path through the grid in order to create a maze. Recursive backtracking basically carves a random path through the maze until it reaches a dead end where it can't cross over itself, and then it backtracks along the path until it finds a new cell that hasn't been visited yet. Eventually, once it's visited every cell, it'll backtrack all the way back to the start, and then the algorithm ends. Got a video of that here, just to demonstrate. There it goes. There were a number of other algorithms that we looked at, like the hunt and kill algorithm, Prim's algorithm, Eller's algorithm, and the recursive division algorithm. But like I said, we didn't end up going with any of those. So we also had our object spawning script. This is responsible for actually putting in all the monsters and treasure chests into the maze. It's pretty simple. We basically just pick a random cell in the maze, check if it's already had something been placed there, and if not, then we just put in whatever object we want. We just spawn it in the center of that cell.
Yeah, so for the HUD, as you saw, we have the gun and the health bar as part of the MVR manager, which is basically like your like player capsule. So the way the interactions work, we couldn't exactly get collisions to work like with regular Unity, so we use distance instead. So when you collide with a potion, it's really just how close you are to the potion. If you're close enough to it, then you get the health, and that's reflected in the HUD with the health bar. And then with the gun, you click the trigger and it fires to the enemies. And colliding with enemies, again, if you're close enough to the enemy, then it will do damage to you, and that's also reflected in the health bar.
So the way the enemy movement works is the blue enemies will remain dormant until within a specific radius of the player. Once it's in that radius, then it'll check using ray casts if there are any collisions or walls between the player and the enemy. If it can actually see the player, then it'll start rotating towards the player and move towards them. And if it gets within range of the player, then it starts dealing damage at a set interval. So this is the game state diagram, and if you want to, you can pause and look at all the different ways that you can go through the game, but you saw in our demo the way that the game runs.
Yeah, so this is some of the technologies we used. Of course, Unity was the game engine you saw. C# was the scripting language that we used for all the interactions, being able to shoot the monsters, being able to pick up potions, run over potions. Plastic SCM was the repository we used. We use this over GitHub because Plastic SCM, in terms of version control, lets you hold lot larger files. Middle VR was that library that lets you be able to write your Unity code and put it into this cave environment. Of course, the cave VR itself and the Visual Studio was our code editor, and it was really good because it works well with C#.
So we ran our project in 2-week agile sprints, and we communicated through Discord any updates that we had, progress, and maybe any bugs that we had to fix throughout the way. And we had a schedule to meet once every week, and our plan and timeline is listed there, as well as assigned to like who did each part. So our testing plan, we successfully completed the requirements that we had wanted to meet at the beginning of the project, and we ran through those on our timeline based on that, and we ended up testing it, and as you saw in our demo, it successfully ran.
Some of the problems we encountered were, like I mentioned earlier, collisions, regular Unity collisions, like functions like on-collision enter, don't work with KVR for whatever reason, so we used distance between the player and whatever objects we were scripting for. Clipping, there was some clipping happening with like the walls because of the limitations of just where VR is at right now. We were able to mitigate some of that. Do you want to talk about how you did that?
Yeah, we ended up just using distance checks. So like instead of checking whether the player's collider hit an enemy's collider, we just checked if the player was a certain distance away from the enemy, and if that was true, then you would like apply damage or whatnot.
Yeah, and then another limitation we had was we could really only program on this one computer in here since this is where the cave is at. It was kind of difficult to try to write code on our own at home because you can't test any of it on our own without the cave, so we had to be here. And then lack of experience, I think only a couple of us had used Unity before, and none of us had used it for VR before, so there was a lot of learning as we went. And then possible future work, things that we could add to this if we were to continue working on it, different side quests and challenges instead of just going through the maze. Adding different rooms that you can encounter with different obstacles in it. Making it multiplayer instead of just single player so you can collaborate throughout to find the exit. Making different levels with different difficulties. So like a harder difficulty to have more monsters, and no mini map, and easy level can have a mini map to help you get through. We do have the ability to eliminate enemies now. For tracking the high score, right now we're just tracking the best time and chests collected. Maybe we could combine those and like how many enemies you shot to make one cumulative score. And then just adding like a leaderboard as well, and also like booby traps and stuff. That kind of goes with the separate rooms I talked about.
Yeah. So
Of course, you don't have questions because you're a YouTube video.
that's our project.
Post
Leave
in the
them in the comments below.
Like that bell.
Okay. Good job, team.